Man, next time I will win the trick. Are you really confident? Damn, seems you're right. Just take these 4 cards. Oh, damn! Dude, I just checked exactly these 2 cards. Yes, I know. I always have bad luck. Hey guys, how's it going? As a library author, we are in a catch-22 situation. On one hand, we always want to use the latest API generation, like 14 or 15, as it combines the best execution performance with the most concise source code. But on the other hand, most of our downstreams accept only older generations, like Java 7 or 8. Typically, least will accept Java 9 or newer. So what shall we do? We could provide multiple jar files, one per API generation. But that means 7, 8, 9, 10, 11, 12, 13, 14, 15. No way. Think of the dependency bug fix hell. You need to tell downstreams how to find the latest bug fix for their particular API generation in the central repository. Nope. Let us use a multi-release jar instead. And this is how it works. Let's first write code in the oldest variant we want to support. In our example, loading a file from disk, we're using Java 7 to write 2 files. One specific to Java 7, which is this one. It actually reads the files from disk. And one which shall demonstrate how to use a common file for all versions, which is this one. It simply prints the text. I think it's obvious what it technically does. By the way, whenever you load files from disk using Java 6 and older APIs, you should consider definitely using Java 7 or later file I/O RPs, the so-called NIO API, which is superior in performance. It's really a considerable difference. We also want to support later API generations, let's say 8, so we could use streams instead of dealing with bytes, and 11. So we have these in different files, which is here for the streams API, and here for the latest and greatest code we could use to load files in a single one-stop fashion. As you can see, they live in different folders, one for each version of the API and one for the common or fallback stuff. By the way, if you compare the Java 7 source code and the Java 11 source code, you will see the difference not only in the execution performance, but also in the readability of the code. Here we have Java 11. Java 11 does exactly what you want in a single line and allows you to write down just that, but not more. You just say, I want to get a single string from the file on this location. You don't need the intermediate types, you don't care for them. In Java 7 you have to write them down, even if you don't care. And you have to deal with the UTF-8 explicitly as long as you want to have a single line solution. So Java 11 in comparison to Java 7 is fast and concise. No dealing with bytes or anyway obvious return types. To actually build our jar file, we need to run the compiler multiple times and put the output in separate folders. All common code is compiled for the Java 8 target and located in the usual place for the jar. And all specific code is compiled for a specific generation of Java and located in specific folders in the meta-inf/version folder. I will demonstrate that. As you can see, we have the folder structure here, and here we have inside those folders the files. So this is specific to Java 11, this is specific to Java 9, and we have the common code here outside of the meta-inf folders. So what technically happens is that all older Java VMs that don't know how to deal with multi-release jars will always pick up the common code and execute it as a normal jar. It has no difference, so for they ignore the meta-inf versions folder. But if you have a Java 9 or later JVM, it will know this mechanism and look into the versions folder, so it picks up either the file from versions 9 or versions 11 in our demonstration. So if you execute that code, then you see this mechanism in action. Sorry. I give it an arbitrary file to load from, doesn't care for. I just use a chitignore file. So you see the output from the chitignore file, which is what the code shall do. And you see here, this was the variant of Java 11. This source code, which uses the highly optimized readstring method, and the content is printed on screen using the common file, which is compiled against Java 7 API. Sorry guys, the doorbell. I'm back in a minute. Yes?
Hey man, I got your stuff.
Ah, great. Did you get your beer?
Yeah, and the potato chips.
Oh, great. Alright, I need that. Don't tell my wife. She's so strict about my diet.
Alright man, see you.
Yeah, thanks. See you at don't do Sorry, Gabriel. I just had to pick up a delivery from my neighbor. He's in holiday or something. Okay, how to go on. If you're using Maven, this is how to do that. Let's look into the POM file. So this is the POM file. Let me enlarge it. For the compiler plugin, we use the latest one, and we have multiple executions of the compiler plugin. This is the execution for Java 8 and later. This is for Java 9 and later, and this is for Java 11 and later. Don't worry about the API version. I said we're using Java 7. Unfortunately, the mechanism for multi-release jars was introduced in Java 9, so technically there is no difference between Java 7 and 8 here, so we just compile it for Java 8. Yeah, I know it won't run on Java 7, that's pretty clear. So you can use that mechanism if you want to separate between 9 and newer and 8 and younger. And on top of 9 you can separate into any number of into any number of API generations. Also mind, besides the release number, the compile source roots. This is not brilliantly documented on the web. Actually it does work. So you have to write down here where the source code comes from, that this execution shall compile. And we have the same for 11 here. And you need to take care of the multi-release output true switch, which tells the compiler where to put the outcome, where to put the binary files. So this is it for compiler, and now we go to the linker. The jar file linker or packager also needs some tuning. We tell it we want a multi-release jar, so it knows the output shall be executed as different versions of the JVM. Actually, this will not change anything in the Maven jar plugin or in the jar tool itself. This is just an entry for the class loader to understand that it shall look into the version subfolder. It's just a safety means, because in the theory you could have added a version folder before, and to make clear that now the version folder actually is the one needed for this technology, we have to set the switch to true. The main class below here, this has nothing to do with multi-release jars. This is just to make it an executable jar so I can demonstrate the outcome. And that's pretty much it from Maven. So as you have seen already, we can simply compile and build as before. I clean the output and start package, and you can see it invokes the compiler multiple times and produces the output. I've already shown that. So as you can see, producing multi-release jars is not that big problem, but I don't want to skip one thing. Actually, the support in the IDE is not that great these days, but I think this will improve soon. What? You start cooking? If I want vegetables, no. See, I don't want to eat too much. I'm too fat anyways. So far about multi-release jars. Hope you enjoy it. Hope more projects will adopt to it. Stay safe, and as always, party on.